In a small notebook page drawn more than 500 years ago, Leonardo da Vinci imagined a bridge that seemed to belong to the future. One enormous arch would cross Istanbul's Golden Horn without a single supporting pier in the water. It would be wide enough for a road, tall enough for sailing ships to pass beneath it, and longer than any masonry arch the world had ever seen. Leonardo's proposal reached the Ottoman court, but the bridge was never built. No surviving document tells us whether the Sultan rejected it, ignored it, or even saw it. And that missing answer created a mystery that engineers are still investigating today. Around 1502, Leonardo was searching for a new direction. French forces had overthrown his patron in Milan, and he was moving between courts as an artist, inventor, and military engineer. Across the Mediterranean, Sultan Bayezid II ruled an expanding Ottoman capital. Istanbul's historic center stood on one side of the Golden Horn. On the opposite shore lay Pera and Gulata, a busy district of merchants, ships, workshops, and foreign communities. The distance between them was not great. The crossing was the problem. People and goods traveled by boat or followed the long route around the harbor. A permanent crossing could transform the city, but rows of stone piers would obstruct ships and require difficult foundations. Somewhere along the commercial and diplomatic networks of the Mediterranean, Leonardo heard that the Sultan wanted a bridge, but had not found someone capable of building it. So Leonardo made an offer. The original Italian letter has disappeared. What survives in Istanbul is an Ottoman court copy or summary preserved in the Topkapi archive. It presents Leonardo as a complete engineer. He offered a wind-powered mill, a device for removing water from ships, and a bridge between Gulata and the Old City, high enough for vessels to sail beneath it. The document says the letter was written on the 3rd of July but gives no year. Historians therefore date it to 1502 or 1503. Its wording also matters. Leonardo said he had heard about the Sultan's intention. The surviving text does not prove that Bayezid personally commissioned him, or that an official competition ever took place. The bridge also appears in manuscript L, now held in Paris. On 2 small pages, Leonardo drew it from the side and above, then recorded its dimensions in mirror writing. Leonardo wrote that the bridge would extend 600 braccia in total, with 400 braccia over the water. It would be 40 braccia wide and rise 70 braccia above the surface. A braccio was an old Italian arm-length measure whose value differed between cities. Using the Florentine unit produces about 350 meters overall and a clear water span of roughly 233 meters. Another common conversion produces 366 meters overall and a span near 244. This is why modern accounts appear to disagree. The often repeated figure of 280 meters comes from a modern geometric reconstruction, not a number Leonardo wrote. Whichever conversion is chosen, the main arch would have been several times longer than the greatest masonry spans known from the period. Most stone bridges of Leonardo's time crossed wide rivers through a sequence of smaller semicircular arches. Each arch required piers, and every pier narrowed the channel below. Leonardo replaced that familiar system with one flattened, double-curving arch. In a masonry arch, fitted blocks transfer weight through compression. The load follows the curve and pushes outward into the ground. Stone is strong when compressed, but weak when pulled apart. If the force remains inside the arch, gravity helps lock it together. Seen from above, the bridge widened dramatically at both ends, like a swallow's tail. These flared supports could resist the arch's outward thrust and increase stability against sideways movement. With no piers, the harbor remained open, and the height allowed sailing vessels to pass. Function and geometry worked together. But the surviving sketch is a concept, not a complete construction plan. Leonardo left no detailed foundations, stone dimensions, construction sequence, or clear material specification. Modern researchers infer stone because timber or brick could not realistically achieve the proposed span. The drawing shows that Leonardo understood the problem. It does not show that every problem had already been solved. In 2019, a team at the Massachusetts Institute of Technology asked whether Leonardo's geometry could stand using structural principles available in his time. The researchers created a model at roughly 1/500th scale. They produced 126 individual blocks with a three-dimensional printer and assembled them over temporary supports. There was no glue, no fastener, and no mortar holding the model together. When the temporary support was removed, the arch remained standing through compression and gravity alone. The team then moved one of its supports to imitate uneven foundation movement. The bridge deformed slightly and remained stable until the displacement became too large. The result was remarkable, but it is often exaggerated. The experiment showed that the geometry was structurally plausible. It did not prove that a full-size bridge could have been completed in 1502. The real structure still required immense foundations, accurately cut stone, enormous timber centering, and resistance to wind, earthquakes, settlement, and weather. A model can answer whether the idea has balance. It cannot recreate an entire Renaissance construction site. This is the point where legend usually replaces evidence. Many retellings claim that Sultan Bayezid dismissed the design as impossible. Others say he considered it too dangerous. No known Ottoman reply supports either story. The proposal may have seemed too expensive or risky. It may have entered a court office without reaching the Sultan. Politics, Leonardo's changing patrons, or the lack of a construction plan may have ended it before any decision was recorded. All of these explanations are possible. None of them is proven. The archive preserves the proposal, but not the answer. That silence leaves two questions. Could the arch stand? Modern research suggests that it could. Could it have been built at that scale and location, with the labor, foundations, money, and tools available in 1502? That remains uncertain. Nearly 5 centuries later, Norwegian artist Vebjørn Sand helped transform Leonardo's form into a pedestrian bridge near the town of Os. Opened in 2001, the modern bridge is about 108 meters long, with a 40-meter main span. It uses laminated timber and modern structural connections instead of Renaissance masonry. It shows that Leonardo's shape can become architecture, but it is not a full-scale test. It is far smaller, uses different materials, and crosses a highway rather than a harbor. The original question therefore survives. Leonardo's lost bridge was not merely a fantasy, and it was not a finished blueprint waiting to be built. It occupied the uncertain space between them. A real proposal, an intelligent structural idea, and an ambition far beyond anything attempted at the time. 500 years later, the drawing survives. The geometry has faced modern tests. Yet the decision that sealed its fate has vanished. Perhaps Leonardo's bridge was impossible, or perhaps history simply never gave it the chance to fail.